Recently on Reddit, I bumped into questions when people have been asking about some bizarre practices regarding React hooks that were promoted by their tech leads. And I'm not a detective to figure out why they propose such bizarre practices, but let's talk about React hooks, particularly about useRef, useMemo, and useCallback, and when you want to use them. So what is React application? React application is a tree of components, and those components can be either class components or functional components. But since you don't use hooks with class components, we're not going to care about them. What is a functional component? Well, essentially, it's just a JavaScript function that accepts some properties and then return how to render those properties and maybe some internal state in form of JSX. But what happens to this function when React renders? Essentially, if React will try to render this app, it will call this function called app, and then this function will return some JSX that mentions some simple component, and simple component is also a function that returns another JSX. So React will call this function, and what happens when the JavaScript function is called? Well, all the variables declared inside the function will be redeclared. So every single time the simple component is rendered or this function executed, then X will be redeclared, meaning that it will always stay 0. So if we add an onClick handler to this button and we will increment X every time you click a button, nothing happens because it doesn't force the React to re-render the simple component. React re-renders components when one of the two things happened. Either setState from useState is called, or when dispatch from useReducer is called. So now, even though we call dispatch, we still see that clicked is 0. Why is that? Because when React will re-render this simple component, the variable X will be reinitialized and it will be assigned a 0 one more time. But if we put outside of the scope of the React component, then it of course will start tracking it down because there will be nothing that would reinitialize this variable every single time the function simple component is called by the React rendering process. But we never do that with React this way, because this way variable X is kind of detached from the React rendering process. So we want something that is connected to the React rendering process, like here's the value of the reducer, which is count. So whenever we click, it again updates, but now it's connected to the React rendering process. But sometimes, like in case of this variable X, we don't want it to be reinitialized every time a simple component will be re-rendered. So the first thing we can do is of course move it out like we have shown before. So let's say when variable X holds an array, we don't want that array to be reinitialized every single time because the previous array will be garbage collected and new array will be created instead. So it's just like simply unnecessary. But sometimes state cannot be moved outside of the component to be preserved across the re-rendering process, because it makes sense only within the scope of the component. And for that purpose, React has a hook called useRef that returns you an object with a single mutable property called current. And this is the property that you can mutate the way you like it. So in this case, we again increment it, but useRef then comes with a trade-off that it doesn't affect the rendering process. So mutating that property doesn't cause the React to re-render, because again, React re-renders when setState is called or dispatch is called, not when we mutate a current property of useRef. So typically useRef is used to create a reference to DOM element, like button in this case, or if you want to keep a value returned by setInterval or setTimeout functions. And sometimes people come up with very clever usages of using useRef. Here's, for example, a hook that is taken from the usehooks npm package, and this one uses ref to keep track of how many times the component where this hook will be called, how many times this component has rendered or re-rendered. And there is a reason why React returns an object with a property that you have to mutate, and you cannot mutate the object itself, because then this object will be detached from whatever the sort of like useRef has returned. But this way, when you use exactly the object that returned by useRef, you can mutate the property on that object as much as you like, because useRef will still have the link to that object originally returned by it. So if your tech lead somehow proposed you this bizarre syntaxes to have a mutable object because he doesn't like what useRef hook returning you, point them to the documentation or point them to this video and let's have a discussion about it. But useMemo was not created to give you a possibility to kind of cheat the system and have the mutable object. It's useRef that gives you an object that can be mutated, but with the trade-offs of not causing React to re-render. But what useMemo is good for? Well, useMemo solves completely different type of a problem. Let's take a look at this Fibonacci input component. Sometimes you need a value that is just inexpensive to calculate. In real world, it would be probably some kind of array or a collection that needs to be filtered in a various ways or something like that. But for simplicity's sake, I have created this naive Fibonacci function that calculates Fibonacci in the recursive way. Let's say we want to say, hello, I am James Holden. And you see, we have this typewriter effect, which is kind of cool and nice. But what if we also have a Fibonacci number to calculate? Because the Fibonacci number calculates based on state, because state tracks which number we want to calculate Fibonacci from. And let's say we want to calculate the 37th Fibonacci number, and we already see that it's kind of expensive. So now if we try to type hello, it doesn't even, it's not that even responsive. I'm typing and you don't see the input like immediately. And if we increase the Fibonacci to 39, for example, it becomes even worse. So this value is clearly expensive to calculate. So what can be done when value is expensive to calculate? We can use a technique called memoization. Memoization is when we essentially wrap the the function that is expensive to call with this another function called memoize. In this another function, it has a table which will, or cache if you will, that will keep track of previously calculated results. So only the pure functions can be memoized, and pure functions mean that functions do not have side effects, meaning that the function is sort of like a direct mapping between arguments and the return result. So given the same argument, you will get the same result every time, meaning that we can store arguments and the result in a table. So the next time you call the function with the same arguments, instead of calling this expensive function, we can just take a look in the table. And since a table is a hash map, this operation takes a constant time, which means that it's very quick. So memoization is essentially what React is doing when you are using a useMemo hook. UseMemo hook accepts a function that will calculate that expensive value and the dependency array. So when the dependencies in this dependency array changes, this expensive function is called again, and this expensive value is recalculated again, but then it will be memoized. It will be stored across the re-renderings of the React component until the dependency change again. So now, even though we still have to calculate this expensive value once, for example, value 49, after that, there is nothing that prevents component to re-render smoothly, because that dependency doesn't change, number doesn't change in this case. So React can reuse that value again. So when do you want to use useMemo? Essentially only two situations when you want to use it. Situation number one, when, like we demonstrated right now, the value is expensive to calculate and there is no way around it. The situation number two is, let's say we have the message component, and message component accepts only single property text, that is string, and it also shows how many times it was rendered. So the message is the child of this app, and then whenever the app renders, because we're calling dispatch from it, the message is also re-renders. Even though in this particular case, message, it never changes. Like in our case, it's just some kind of message that just stays there. So we figure out there is no need to re-render that component so many times, so we can memoize it using React Memo function. So now when we re-render the application, the message component doesn't re-render. And it's not going to re-render until the properties of it changes. Because this is how the React.memo works. It checks if the component's properties has changed, and if they changed, then the component is re-rendered. But now let's say message, instead of the property text, it accepts a property user, and user is an object that has a first name and last name, and then we show first name and last name inside the message. And then we create this user inside the app, and then every time it renders, the message is re-renders again, even though it's memoized. Why is that happening? Well, exactly like we said, every time the React calls function app, the variable user is redeclared, a new object instance assigned to it, meaning that message receives a new reference to another object every single time it re-renders. And that's why memoization fails. So again, of course, one way would be to move it out of the React rendering process by moving it outside of the component scope, but we not always can do that, because quite often that object is defined in terms of the internal state of the component. So every time this component re-renders, this object is redefined, meaning that we get a new reference, passing this new reference to the message, and then message re-renders again, disregarding that it was memoized. So this is the second usage for useMemo, holding the reference to that object until the dependencies change. So now every time we re-render the app, the message, because it was memoized, it doesn't change, because the user object doesn't change, because useMemo holds on to that calculated object, and so the reference to that object doesn't change, meaning that message memoization can be respected. Same situation happens if we pass a function instead of an object. We have a memoized component, we accept a function called print that will print the name, and then we pass this function from the app print name that returns just a string, and then again, whenever we re-render app, the message is re-renders, because of the same reason, because the function is redeclared every time the app component is called to render. So this is when you use the useCallback hook. And now it re-renders only when the function changes, because the dependency of this function changes. I have another video about another use case for when I personally use callback all the time, but to summarize, useRef is when you need a mutable object detached from React rendering process, useMemo to remember expensive to calculate values, or prevent objects from reinitialization to pass them to memoized components, and useCallback to prevent functions from reinitialization to pass them to memoized components. This is the only use cases when you would use useRef, useMemo, or useCallback. And as a bonus, at least few times I've been asked on interviews, should we use useMemo and useCallbacks all the time? And the answer is no, we should not use to. Even though some tech leads been claiming something like that on Reddit, we should not use useMemo and useCallback all the time, because using them adds an extra overhead around our functions. So we don't memoize every single function and every single object. For the same reason, we do not memoize every single function we code elsewhere in our program, because most of the time function is called quite sparingly and is called with different arguments. So there is no really point to memoize everything. So only when you measurably could say that the performance of your application is affected by the fact that you render lots of things, only then start to memoize and then when you start to memoize the components, of course use useMemo on useCallback, but only when you can absolutely say that, yes, my application is hurt by unnecessary rendering, and stop believing tech leads or other people who say you bullshit that you need try to prevent React from rendering as much as possible. Rendering is fine, and premature optimization is the cause of all evil. I really hope this video was helpful for you, and no tech lead was harmed during filming this video. Thank you, and see you next time.